Okay, so for the performance eval to finish up for Millwright Power Tools that we're doing in IT 102 is we're going to make a piece of pipe, length of pipe 18 inches from center of elbow to center of elbow. So what I've done is I've grabbed a regular 90-degree elbow and what they call a street elbow. It's still a 90-degree elbow, but it has a male fitting on one end and a female fitting on the other end. And so I've also went through and I just marked out some different things on the table just as reference. I made a mark at 6 inches, I made a mark at 24 inches, and then I took the square and I straightened those ran lines so I have something to reference on both sides. So you can do it this way or you can just calculate it all out. I did it for references so you could see better during the video. So we're going to set our one elbow there and our one elbow here. Again, it doesn't matter. The other thing that we're putting in there, this is a union fitting. It's used to connect two pieces of pipe. And for example, this would go on one piece of pipe, this would screw in there, this would screw on the end here, and allow us to tighten that. Unions are added out in the field when we have to replace pipes. For example, and I don't know if you'll be able to see it from the video, but it would go in between here, where this piece of pipe goes in here, and here, we'd be able to put a union in there so we could take it back out or remove it and replace different pieces of pipe. So one would tighten one way, the other would tighten the other way. Then we have these pieces on there and we pull the two pieces together and tighten it up. Real quick on the union. There is a male half and there is a female half. Male half has the flange. And it's going to go together like that. And it's going to be tightened by the outside threads going around here. So when we do this, in the paper, I'll give you, it says flow is going to be from left to right. On my left, flow is going to be that way. So we always want the male fitting to be where it flows into the female fitting, because that flange is made in there where it comes out. And that would make the smoothest flow possible, where it goes that way. If it was the other way, then we would be running into that little bit of a flange at the end there, which could disrupt flow. One last thing on the unions. These are match sets. If we replace this half, we replace this half. We throw away both and start all over. They're manufactured together, they're a match set, so we always keep the match sets together. So, but that's a union. Unions, like I say, a lot of construction sites, when they first build the plant, there's no unions in there because it's extra parts and extra time. So, but after people start repairing it, unions are put in so they have access to things. A couple other fittings here, and just to show you the difference, here's a 90-degree fitting, and the one next to it would be a 45. 45s are going to be used for 45-degree angles, like that offset I showed you over there. These are common fittings. Another would be a Y. How does it get the name? It has the shape of a Y, the letter Y, as we go through. So, and then the last one would be the letter T, where we put a branch off of something at a 90-degree angle. So those are the most common fittings. Are there other fittings out there? Of course there are, but these are the ones that you're going to use the most often. So back to our project. These are them. So now we have this on the center and this on the center, and we have an 18-inch distance starting from center to center here, from there over to here. Okay? We already know we're going to have to go less than 18-inch piece there, though. But how much less? The reason I draw the lines, it makes it easier because I can take the tape measure now and measure from the center of my line to the edge of the fitting. I can do it up here also, but with having the line down here, it makes it easier for those who are not very experienced at it. So we get 1.5 inches. Come over here, and we do the same measurement, and again we get 1.5 inches. So we have 1.5 inches on each side. 18 minus 1.5, or 1.5 plus 1.5 is 3. 18 minus 3 is 15 inches. Now the other calculation we need to make in here, we need to measure the union. How much does it take? Because that also is cutting into our length. You can't see it in the video, but it's 2.5 inches long. So I've done my 18 minus 3 inches, I'm at 15 inches. Now I take the length of the union out of there, which is 2.5 inches. That takes me down to 12.5 inches. Okay? But we have one more thing to calculate. That would just be not tightening them at all. That would be from there to there without engaging the threads. Well, we have to engage the threads. In the paper I'll give you, it says to take a known piece of pipe, get the length of that piece of pipe, 8.25 inches, and then screw a fitting on there, and again we would measure it down to the center of the fitting. In the book or in the paper I give you, it's going to tell you to use the pipe wrenches and tighten it up so you get an accurate reading. I'm not going to do that. 9.5 would be our center distance. And again, we would take our 1.5 inches off of there. So that takes us back to 8 inches. We were at 8.25, and now we're at 8, so we've engaged 1/4 inch. And if we tightened it the rest of the way, we would be looking at 3/8, probably closer to 1/2 inch by using the pipe wrenches to tighten it up. So if we went for 1/2 inch, and we went back here, and we engaged 1/2 inch here, 1/2 inch here, 1/2 inch here into this pipe, and 1/2 inch there, or 1/2 times 4 would be 4 times 1 would be 4, 2 times 1 would be 2, so 4 2s, or 2 inches. So we have 12.5 inches plus 2 inches. We would be back up to 14.5 inches. And then we could either split that as this piece being 7 inches, this piece being 7.5. We could go with 7.25 on each side. Whatever method you want to use at that point, it's basically up to you. We can only make 6-inch pieces and larger in the pipe machine. So we are limited. We would have to do, with our 14.5, because we can only do 6 inches, we could do a 6-inch piece and an 8.5 inch piece. However you wanted to do it. Again, there's many options there, whatever works. When you get done, like I say, the flow is going to be left to right. So we would have it all tightened up with the pipe wrenches, tightened here, tightened into here, tightened into here, tightened into here, and this union would be tightened up with the pipe wrench. I'm not going to have you put thread tape or thread locker on it. This is just an experiment, but out in the field, we would put Teflon tape or pipe dope on each of these fittings. We would put it on the male fitting here, on the male fitting there, on the male fitting here, the male fitting there. And you will see out in the field on this union, people will anti-seize this. That's acceptable because these are straight threads. The rest of the threads that we are cutting in the pipe are interference fit. That means it starts cut deeper and it doesn't cut as deep all the way out. Probably can't see it in the video, but it doesn't cut it all the way as deep up here. So as we tighten that on there's more and more interference. That's why we don't put anti-seize on there. But we can get away with it here because it's not a tapered thread or an interference fit thread. So that's why they put it out on here. So that is the real rough and dirty version of how to lay this out. Again, you don't have to use this. You can use just measurements and do it that way, but it was more for an example here on the table to show you guys. Do you have any questions? text, call, email me.